Yes, hello everyone. Welcome to Physics Classroom. I am Lawal Adetunji, your physics tutor. To our returning viewers, welcome back to your classroom. To our new viewers, welcome to Physics Classroom. Please do well to press your subscribe button, turn on your notification button, press your like and share button, and put your comment in the comment box. We have a particular program, or let me say, upcoming event on our platform, and we want to use that one to assess how far our viewers have been watching on and how well they have understood us better in this classroom. Not only on this platform of physics classroom, and likewise all other subjects like physics, chemistry, maths, biology, further mathematics, all the subjects we are treating on this platform. So because of that, we are having a quiz competition that will talk about all these subjects, and where we have participants all over the world. So in preparation for that quiz, we are bringing up practice questions for our viewers to work with and put their answers in the comment box. All right, talking about physics right now. This physics I want to discuss in this video, we'll talk about the following topics: dispersion of light, mechanical wave and electromagnetic wave, capacitors, relationship between temperature and velocity under sound waves. We'll talk about critical, angular, and total internal reflection. We'll talk about Mirror's formula. We'll talk about the relationship between the speed of wave, the frequency, and the wavelength. We'll talk about the transverse wave. We'll talk about the refraction and the Snell's law. We'll talk about the reflection and the plane mirror. And lastly, we'll talk about the closed pipe and open pipe. What are the practice questions we want to bring out from these topics? I will start from dispersion. We talk about dispersion of light. Dispersion is talking about the separation of white light into its components, right? When I say its component, that is the rugby, red, orange, yellow, green, blue, indigo, and violet. So because of that, we may be having question that may talk about. We can have a question that may talk about the way the light passes, the way the light moves. We can say light passes through a prism. When that is a question, that may be a question that will look like that, but in that situation, we'll be talking about light passes through a prism. When light passes through a prism, definitely dispersion will occur. Another one, we can have a question that will talk about how the reason for dispersion, and the reason for dispersion is talking about the formation of spectrum. For you to enjoy this video very well, since we are not having any content on write-up, you can put it on subtitles so that as I'm speaking, you also will be seeing it on your screen. I think that will settle the issue of dispersion. Let me see if I can also have anything related about dispersion. Let's say they want to talk about the way your colors are arranged. Violet is a list when talking about the arrangement, though it depends on which arrangement that you're talking about. Definitely you need to monitor the arrangement in form of from arrangement in frequency or the arrangement in wavelengths. When I say the arrangement from frequency, that is the trend from R to V for frequency, and likewise for violet, which one will be the increase or which one will be the decrease. Work on that as well. So leaving that aside, I'm done with the issue of dispersion. I want to talk about the issue of mechanical wave and electromagnetic wave. When you talk about waves, we say we have types of wave, like two types of wave in form of material medium. Mechanical wave is a wave that requires material medium, while the opposite of mechanical wave is electromagnetic wave. That is, electromagnetic wave is a wave that does not require any material medium for propagation. Please do well to watch our video on sound waves. That one explain better everything on mechanical wave and electromagnetic wave under that sound wave. So what are the likely practice questions we can bring out from there? We can bring out the practice question from there. Maybe a situation whereby they may ask us which of the following is an example of a mechanical wave, or you need to know that the example of mechanical wave is sound wave. Example of electromagnetic wave is light and all other electromagnetic wave like X-ray, infrared, violet, all those things we mentioned under the dispersion of light. They are examples of electromagnetic waves. Or again, what they can ask you, that maybe here they may ask you which one do not require a material medium, which of the examples that do not require a material medium. Definitely, the answer that will fit to that thing will be one of the examples of electromagnetic waves. That this electromagnetic wave does not require material medium. So all these example, they do not require what material medium. That is, light does not need material medium. X-ray and other electromagnetic wave, they do not require electromagnetic medium. That one settle that. And what again can they ask you? They can talk about the speed of the electromagnetic wave, the speed of light. That is 3 times 10 raised to power 8 meter per second. Please do well to turn on your notification button. Anytime we are on live, you'll be the first one to see our notification, and likewise anytime we release video, you'll be the first one. Those people that are writing WAEC, JAMB, post JAMB, NECO, JUPEB, IGMB, A level, all type of exams, please do well to watch our videos. We are here for you. People that wrote WAEC and that are also writing NECO, they have been appreciating our good works. You also want to join them by also having your own distinction, as they also are celebrating that. And what again can they talk about? We have said that mechanical wave requires material medium. Okay, and I've talked about sound wave. I think with that I can say we have ended the story about mechanical wave and electromagnetic wave concerning the practice question. I'm not talking about concerning the classroom teaching. We have done a lot of classroom teaching on all these things. Please do well to watch all the videos. Here is just like bringing out, telling us a likely question we should be expecting in that quiz and what we need to prepare for. Now moving to capacitor right now. We know capacitor as a device that stores electric charge. Since we have known that it stores electric charge, you need to know that the formula that relates capacitor, the charge, and the potential difference is the formula that says Q equals to CV. I repeat, Q, that is charge, equals to capacitor times potential difference, and the Q equals to CV. That's the formula that relates them together. In case you see any question that talks about that, maybe you are given any of the 3 parameters, you are given 2, you find the third one, you make it a set of formula. What again can they ask you about capacitor? They can ask you about the arrangement of capacitors. When capacitors are arranged in series, the formula is 1 over C total equals 1 over C1 plus 1 over C2 plus 1 over C3. So when you have such a thing, take an instance. If I have a question that says 3 capacitors, each of them 6 microfarad, and they are arranged in series, what will be their total capacitor? Definitely we say 1 over C equals 1 over 6 plus 1 over 6 plus 1 over 6. When you find your LCM will be 6. And when you start putting things together, you'll be having 3 over 6, and at the end of the day, you have 6 over 3. And when you have 6 over 3, definitely you know your answer will be 2. I think that one has settled that in that aspect of capacitor. What about if they are arranged in parallel? You add them together. I think that one settled that. What are the likely questions they can ask you about that one? Let me see. You can have a likely question about that. Okay, let's even use the same example again. You just need to add them together. If the 66, you add them together. If they ask you such in parallel, you add. If you are asked in series, you add up their inverse. That is 1 over C1. I'm talking about series. Series is 1 over C total equals to 1 over C1 plus 1 over C2 plus 1 over C3. While for parallel, you just say C total equals to C1 plus C2 plus C3. Alright, what again can they ask you on the issue of capacitor? They can ask you question about energy stored in the capacitor. The formula for energy stored in the capacitor, we have 3 formulas, but all the formulas were created from E equals to half CV square. I repeat, E, energy, equals to half times capacitor times potential difference square. Whatever the value you are given, you will interpret that. But remember your microfarad. Whenever you hear the word micro, whether for microfarad or microcoulomb, micro means 10 raised to the minus 6. Don't be carried away and don't forget. So in that situation, E equals to half CV square can settle question like that, and from there you will have your answer. Likewise, be very sound in your standard form and how to interpret ordinary number to standard form so that I can get it right. I think that one settled that. What again can they ask us? They can ask us questions about I think we have settled the issue of capacitor. I need to move to another thing. I want to move to the relationship between velocity of sound and the temperature. One of the factors affecting the velocity of sound. Please do well to watch the content, the video on sound wave, because there are a lot of questions waiting for you there in that sound waves that will help you. I have said my own. So we have velocity, that is, we have V1 over root T1 equals to V2 over root T2. Now, concerning the issue of the relationship between the velocity of sound and the temperature, absolute temperature, we have said that V is directly proportional to the absolute temperature. That is, the higher the velocity, the higher the temperature. That's just the simple meaning. So they can I'm giving you this question. I want you to answer it and put the answer in the comment box. If my V1 is 360 meter per second and my T1 is 27 degrees Celsius, find V2 if your T2 is 127 degrees Celsius. I repeat, V1 360 meter per second, T1 27 degrees Celsius, V2 is what you want to find, and your T2 is 127 degrees Celsius. Make sure you convert your Celsius to Kelvin. Drop your answer in the comment box. Another question I want to put in the section there is also saying that your T1 is 20 degrees Celsius, your T1 is 0 degrees Celsius, your V1 is 331 meter per second, your T2 is 20 degrees Celsius, and while your V2 is unknown. You're also finding V2 for that one. So I'm giving you two questions right now. If I were you, you pause this video, you solve the two questions and put your comment or your answer in the comment box for me to confirm for you. I think that one settled that. So moving forward, I think I've told you the relationship between the velocity of sound and temperature. I said both of them, as velocity is increasing, temperatures will increase. They are direct proportional. I think I've settled the issue of velocity and temperature. Now for the issue of critical angle and total internal reflection, you need to know your critical angle very well, and those are the conditions that surround that. And when we talk about the critical angle formula, the formula that relates critical angle with refractive index, you know that refractive index equals to 1 over sine C. 1 over sine C. Take an instance, if you're refractive, now do this question again and put your answer in the comment box. If your refractive index or the refractive index of a glass is 1.5, find C, find the critical angle. I've told you that the refractive index is equals to 1 over sine C, and now the refractive index is 1.5. Find C. I think that one will settle that aspect of the calculation. That's the formula that relates refractive index and critical angle. I still want to bring up something. That's why I'm looking at my. And in case in critical angle, your angle of refraction must be equals to 90. Your angle of refraction is 90 at the critical angle. That's what we call the critical angle. And which one again I need to talk about on that same place? I think the question I gave to you. How would the light travels? I think they tell you how would the light travel. That the light must travel ahead. Concerning the issue of critical angle and total internal reflection, the light must travel from the denser medium to the less dense medium, or to rarer medium, many I call it. Then that is from denser to less dense, or from denser to rarer medium. I think I've clarified that one. Okay. Which one again must you have for you to have a under this critical angle and total internal reflection? The angle of incidence must be greater than the critical angle. About the total internal reflection, that's the condition that the angle of incidence must be greater than the critical angle. I think that one settled the issue of critical angle, total internal reflection. But since I'm not done with the issue of refraction and Snell's law, I only talk about the relationship between Snell's law or the refractive index and the critical angle. I will fully enter refraction of light. When you talk about refraction of light, refraction of light is talking about refraction means when the light travels from one medium to another, and as it travels from one medium to another, what are those things we are cool? The light will bend. Now you have a condition: will it bend towards normal? Will it bend away towards bend away? That's where you talk about the density of the material you are talking about. And what are those things that also make refraction to occur? Change in speed, change in direction, change of medium. Because from one medium to the other, that's the reason why there must be bending. Please do well to watch our video on refraction of light. You know where I carried out that experiment where I put pencil or pen inside the beaker with water. You saw the bend. Please go and do well to watch it very well. And that's talking about refraction. What are the things you may be expecting about the issue of refraction? That's talking about bending towards normal. And when can you have the bend towards normal? Like I said, you need to know the condition. And when can the light ray bend towards normal? And when can the light ray bend away from normal? Please take notice of that. And you need to know the formula of your the refractive index. The refractive index goes to sine I over sine R. Your I is the angle of incidence, while your R is the angle of refraction. So work on that as well. And that one can also be called Snell's law formula. Snell's law formula. And likewise, you need to know when the light slows down or speed up. When the light slows down or speed up, all these are talking about refraction and Snell's law. Refraction and Snell's law. And I think I have said to that aspect. Well, now I was talking about the relationship between velocity of sound and the velocity of wave, the frequency and the wavelength. What formula or which formula relates them together? V is equals to F lambda. Out of these three, the lambda, what I mean by lambda is the wavelength. Out of these three that I mentioned, two will be given, one will be unknown. You make it the sort of formula. And likewise, you need to know about your transverse wave. You know, we have, when you talk about transverse wave, opposite of transverse wave is longitudinal wave. Transverse wave, a great example, that is light. A good example of transverse wave, you talk about the light, you talk about the light waves, you talk about all those electromagnetic waves. They are under electromagnetic waves. I want to see if there is a question you want to bring out here to discuss, but if not, you need also to know to work on what's the unit of frequency. The unit of frequency is hertz. The unit of frequency is hertz. So please, let's take notice of that. And leaving that side, I think I can go to Mirror's formula. Everybody knows that the formula for mirror or Mirror's formula anywhere in the world is 1 over F equals to 1 over U plus 1 over V. I repeat, the Mirror's formula is 1 over F, 1 over focal length equals to 1 over object distance plus 1 over image distance. Please do well to work possible questions and give out answer. There are a lot of questions related to that. Practice it and bring out the best. Now, still on that issue of Mirror's formula, I think I've sent you the issue of Mirror's formula. I've told you about Mirror's formula. Okay, you need also to know when we were discussing mirror, especially the formation of image, we have 6 points, but I told you we have 5 visible points. The first on the principal axis, we have before the center of curvature, we have on center of curvature between C and F, between center of curvature and the principal principal focus, and on F the principal focus itself and the in between principal focus and the pole. So when can we say that we have the same? When will they be equal? When the object is placed on the C, definitely the image also will form on C, and they will have equal size, equal distance, equal everything. That's why they'll be equal. That's why the magnification will become 1. Please take notice of that. I don't want the video to be too long. That's why I'm a little bit rushing. I think from there I can now talk about the issue when you stand in front of your play mirror. When you stand in front of play mirror, I'm now under reflection and play mirror. Whenever you're talking about play mirror, play mirror, you're standing in front of your play mirror. What will be the characteristics of your image? Your image is inside the mirror. Your image is virtual, and it is upright. It is upright and virtual. I repeat, the characteristic of your image is virtual and upright. Why is it virtual? Your image is formed in the mirror. Why is it upright? The way you are standing is the way you see yourself in the mirror. And likewise, when you talk about reflection, this angle of loss of reflection, the first one says that ray, reflected ray, and normal all meet on the same plane, while the second one says that angle of incidence is equal to the angle of reflection. If my angle of incidence is 45, what will be my angle of reflection? Put your answer in the comment box. So I move to the last thing: closed pipe and open pipe. When you talk about closed pipe, when you talk about closed pipe, that a pipe that is closed at one end, open pipe, a pipe that is open at both ends. And when you talk about closed pipe has its own range of answers, harmonics. When I say our F naught, F1, F whatever, when you check the F naught series of the closed pipe, we have F naughts followed by 3 F naughts, 5 F naught, that is in form of odd numbers. Closed pipe arrangement of harmonies is in form of odd numbers, only odd. That is F naught. The next one will be 3 F naughts. That is 1, 3, 5, odd numbers. While for open pipe is like normal number. But let's put your focus on the closed pipe, odd numbers. Bye for now. See you in the next video.